I'm Kellen Barsley, one of the project managers for the Cal Poly Prove lab. And today we'll be kind of showing how the NX and other Siemens software have been used for our current project Mila in order to help facilitate its success.
Hey everyone, my name is Caleb Erlenborn. I'm also one of the project managers here at Prove. Let's get right into our project, which is the endurance car Mila. So the objectives of this project are to break the electric vehicle endurance record, which is traveling over 1,000 miles on a single charge. We don't just want to break this record. We want to be able to look cool in the process. So another one of our objectives of this project is to resemble a sports car. And obviously, it being a student project, we want to make sure that it's safe for anyone to drive, and all of our manufacturing and such is conducted in a very safe manner to prioritize student safety. And another huge objective of this project is to allow all the members to get hands-on learning to prepare them for the industry.
Yeah, so kind of the first topic we'll be going over is our usage of Accelerator Academy. So Accelerator Academy is a website hosted by Siemens that's used to help train people in using these various softwares. NX and Star CCM are particularly what we've been focusing on with this project. So by using this Accelerator Academy training, we're able to do a lot of that without having to train our members individually ourselves. So we estimate by using some of these features in Accelerator Academy, it saved our management over 150 hours over the 3 years we've been using this to train our members. And in addition to the time savings that it's helped us as managers, it's also definitely helped diversify some of our team's skills, because even the most experienced members on the teams still don't know how to use every feature in each of these softwares. So by having this training set up, we're able to have people specializing in different areas of the project learn different features in the software. So the next kind of topic we'll go over is how we've used Siemens NX for the general assembly and packaging for the endurance car Mila. So some of the challenges that we've had as we were designing this car is we have over 4,000 different parts that go into the final assembly of the car, which is ever changing as we do more designs. It's probably more than 4,000 by now. But we need to make sure that all of those parts can be constrained together into a single assembly, and many of them have tight positional tolerances that need to be met as we put them in that assembly. Additionally, we generally have over 30 students at any given point working together on this project, so we need to make sure that all of them have access to actually be able to model that as well.
So another way that we've been able to use the Siemens software is in the structural design of our suspensions. So when designing the suspensions, we wanted to be able to ensure that we were able to guarantee structural integrity under multiple different load cases, and a huge part of that is just guaranteeing student safety. And one of the ways that we were able to use NX to do this is through the SimCenter 3D, which is the FEA environment that is integrated with NX. And this allowed us to iterate through 10 plus designs super quickly with the synchronous modeling tool, where it automatically updates your simulation files when you make a change to your modeling. And we estimate that this has saved us over 80 hours throughout the process. Another tool that we've been able to use within NX is the animation designer. So this allows us to easily measure clearances with several moving components, and also allows us to ensure that we have adequate clearances in all possible configurations for these moving components. And we were able to use this when designing the suspension and the hinges to ensure that there are no collisions during their motion paths.
So yeah, another feature that we've used with the animation designer was just being able to show how things are assembled within the car. So you can see here we have an example of the battery pack. So we will be having multiple of these battery boxes put in the car to power it, and you can see kind of how each of these boxes is assembled in this animation right here. And then Here's kind of a picture of the results of the car. This doesn't include the outer shell of the car, what we call the aero shell, because it kind of hides the rest of the components. But you can see here how we have so many different type positionally toleranced components all put together into this one assembly, which is made possible by the usage of NX. Next, we'll go into how we used NX tools for the aerodynamic design of that aero shell on the outer part of the car. So some of the challenges that we've come across as we were trying to design this car was we wanted to make sure that we get minimal drag. Obviously, as we're trying to have an endurance record, we want the car to be as efficient as possible. So by minimizing our drag while still having space to fit all of the components in the car, we needed a pretty complex shape for the outer shell. We also wanted it to resemble a sports car, so that was one of the bigger challenges, is rather than just being able to make a nice flat aerodynamic blob, we wanted it to actually look like a cool sports car. So that was another one of the challenges that we came across. We also were planning on using composites, so the aero shell, rather than being made with metal panels, will be actually made out of carbon fiber layups. And we also want those panels to be removable, since there are such tight spacing inside of the car. In order to be able to do maintenance on it, we need to be able to remove some of those panels. So that kind of affected how they were designed, as well as we wanted to have hinging doors, hood, and a trunk on that shell. So the solution to this was using the Realize Shape and Shape Studio tools available in NX. So you can see off to the right, we have kind of a primitive model of what the original design looked like as we were making this outer shell. But basically, by using the Realize Shape and Shape Studio, we're able to make a much more complex shape with multiple iterations a lot faster, versus having to sketch every single plane in the shape and then putting them together. This allowed us to manipulate the vertices that we wanted to play with until we got the correct shape for each area of those panels. So here you can see some of the results that came out of using this. So we have more than 20 unique panels on the car. In this image off to the right, you can see each of them is colored in a different shade. And so in order to implement all of the different features that we wanted, such as joggles between the panels, stiffeners underneath them, the air ducts that you can see up in the front, as well as the bulkheads, it was definitely important to have an easy to use modeling tool like NX. So we estimate that versus trying to draw the sketches and piece them together ourselves, this probably saved us over 200 hours in the design of this aero shell, and it led to this very aesthetically pleasing design that we have now. It additionally is helping as we move into manufacturing these panels. These panels will be made on molds, as they are carbon fiber. So the features of Realize Shape and Shape Studio have helped us with designing the molds that will be used to make these panels as well.
Yeah, and another huge part of the aerodynamic design is being able to accurately simulate the aerodynamic properties of the car, which is what we used Star CCM, another Siemens software, for. The challenges for this project are we want to ensure that we have low drag regardless of many different track conditions and be able to have precise values for those aerodynamic properties. Through its tools like drag force determination and crosswind analysis, we were able to get precise values for the sensitivity of different aerodynamic properties of the car, and the compatibility of it between NX and Star CCM was another huge advantage to be able to quickly go back and forth between design and simulation. And as you can see here, the results from using Star CCM was over 44% drag reduction compared to the initial concept designs, and we were able to get those precise quantified numbers to different track conditions, and we estimate that this saved us over 100 hours compared to alternative methods of evaluating drag.
This is one of the later iterations of the car. Some of the earlier renders that you saw in the presentation aren't quite up to date, but you can see here how we have both that longer back end of the car as well as the wheel covers. That significantly reduced that overall drag. So some of the future work that we're looking at as a part of this project is obviously we will be continuing to use NX as our main CAD software. As we move into our manufacturing, we still need to be able to make drawings, export files, and make sure that we can measure our close tolerances and make sure that all of our parts are made within spec so that we can actually get the car built correctly. We're also going to be using some of the NX integrated CAM feature for manufacturing, mainly in the molds that I had talked about earlier for the panels. As we design those molds and we need to machine them, having access to the NX CAM feature will be very helpful for that. And then our main goal right now is working towards actually getting Mila rolling, putting that chassis on wheels, and getting to see it move. So a bit of a summary, just in terms of design, we estimate that there's been over 300 hours of design time saved for members of our team by using NX and Star CCM versus other competitor software or other methods of completing these different designs. We also estimate that there's been at least 150 hours of training time saved for our management, not including just the fact that we can diversify our team's skills so much with the various features available to us. And then of course we have the over 44% reduction in drag to the vehicle versus our initial designs, which is very helpful versus us having to try to build models and run wind tunnel tests or another method of determining our actual drag. And this has allowed us to build our final accurate model for the car to actually know that we feel like we can break that record. Other than that, it's definitely helped us with making sure that the whole car is packaged correctly, as we saw with the animation designer. You can see here the wheels are a little bit tight within the aeroshell, so that was one of the big things that kind of helped us out with, was making sure we could actually get the wheels to fit and move how we needed them to move while still minimizing that amount of drag in the car. Thanks everyone for showing up. I'll pass it off to Chris real quick.
Good presentation, by the way. Thank you. You said you were a project manager for the Prove Lab. Can you tell me what kind of responsibilities you had and what your team looks like?
Yeah, so Caleb and I both operate as project managers for Prove. So our team is basically structured as a student club. So we operate at the top, managing everything that goes into getting this project done. We usually have about 30 engineers working on the team at once. So we have kind of like sub-team leads that we assign based on areas of the car. So the sub-team leads will report to us on progress made by their members, and we're there to kind of set the goals for the project, write the requirements, make sure that the leads and the members are supported in everything that they do on the design of the car. We have a pretty good systems level overview of everything on the project, so we can provide both design and manufacturing feedback to those members as we move through. And we're also kind of in charge of just staying in contact with the school, as we are a school-based club. We receive funding and support from the school, so it's our job to make sure that both our advisor and the school's like aerospace engineering department is up to date with what we're working on. Did that kind of answer what you're looking for?
Yeah, absolutely. That's quite a team structure you guys have there.
I'm curious, what is the record you're going for?
The current world record for the longest distance traveled by an electric car on a single battery charge is 999.5 miles. So we're aiming to break that record by hitting 1,000 miles with this vehicle. However, according to the model we've been running, we're actually hoping we can get closer to over 1,200 miles as we run that record run. And then as we said, we're hoping that we can make it look like a real car as we do it, not just an aerodynamic blob that we put together with a bunch of batteries. in our case, we will be running it on a flat track, as that's how the previous record was broken. Obviously, having mountainous terrain would change the requirements for how we're designing that suspension for the car, as well as reduce our efficiency. So the range that we'd be seeing out of that 1,000-mile record would be on a flat track.
Hi, thank you so much for your presentation. I was wondering how you get new members who maybe don't have a lot of practical engineering experience to engage with these online learning materials.
Yeah, so generally as we bring members onto the team, we will do basically a recruitment process in which they work on a project relating to something on the car. So oftentimes as they're working on that project, we will give them like screenshots or just show them during meetings areas of the car that their project relates to, so that they can at least become a little bit familiar with what the project actually looks like. And then once we take them onto the team, we get them set up with all of the software they need, as well as just getting the assembly up and running on their computer. And most of the time we start them with some of the basic tutorials available on Accelerator Academy. So basically just showing them, like, here's how you do a basic model, here's how you sketch and extrude, all of the basic features in NX. So those who don't have as much technical experience might take a little bit longer to get through this, but we have meetings that are pretty regular for our team. So those members who are struggling to kind of pick up some of the initial concepts tend to just come in and ask more experienced members like ourselves, and we can help them out with that.
Thank you.
Great presentation, by the way. And just going off of the last question, I was kind of interested to learn what your kind of learning curve was in learning, NX and Start CCM, and also, if you had any experience with any other software, and if that helped you in learning NX and Start CCM.
Yeah, I think that a lot of the basics to like parametric-driven CAD softwares are definitely applicable. Using regardless of like whether new members have a background in other similar CAD softwares, definitely would help the sort of like fundamental understandings of like how to make a physical model from something that you have like in your head. But I would say that the training tools that you learn through the Accelerator Academy and other similar tools are applicable more to like a lot of times to learn the nuances of specifically NX, and are very helpful if you have a concept that you want to learn. You can search it in a pretty intuitive user interface and kind of get some step-by-step instructions on exactly how to get to that task you're trying to.
This is Accelerator Academy, the memberships section, and if you go into NX, you can see that there's 210 courses. There's quite a bit of content. I myself have gone through some of the basic training. And I can say, I went through all the way from the basic training to like assemblies. So really just kind of the fundamental aspects of the software. And it was very, very good in my opinion, because I have CAD experience, but teaching myself the software, it was really just trying to understand what you need to be doing in a different interface. So it's just a different interface, different buttons, different layout. But there's definitely things in there that are very, very useful. There's things like the command finder, where in a typical CAD package you've got tons and tons of buttons, and you know what you want to do, but maybe you don't know where the button is. So they have things like the command finder where you can just go in and type in like revolve, extrude, whatever it is, and that will literally pull out the menu with a flashing button on your screen, showing you exactly where that command is. So there's things like that are really, really helpful in kind of getting new users up to speed. Another thing in here, there's a fast start section. So you can see that for users of other platforms, they show you things like that command finder. They show you the things that are different in the interface, and different naming conventions and things that are used. And also how to take your CAD from a different CAD platform and pull it into NX so that you can start using that. So
Yes, hi. This question's a little bit maybe for Cal Poly and a little bit for Siemens. I'm just wondering how the team wound up choosing Siemens software. Like if they evaluated somebody else's, or if they found out about it from other teams, or how did that kind of all come about in that partnership?
Yeah, so kind of in the past, on the previous project, we had used other CAD softwares. Like I believe it was mostly done in SolidWorks, and then we had used, what was it? Was it ANSYS Fluent for the CFD on the past project, Caleb? Okay. Yeah, that was before the time that Caleb and I were on the team, but I believe it was ANSYS Fluent was the CFD software used, and then SolidWorks was the main CAD software. And there were just some limitations for what we were able to do with a larger assembly, kind of as I mentioned, as well as that modeling of the outer shell of the vehicle. The previous project, the solar car, was a pretty simple shape for the outer shell compared to Mila. So as we moved into a more complex shape for the car, we decided to look into using NX as a better solution for that.
Yeah, hi. Great presentation, guys. Question, when you were describing the software for the shell, the aerodynamics in the shell, you talked about the panel sections and you mentioned the term joggle. I've heard that used for sheet metal. I'm wondering if you can describe for the call here what that is or how that's used in this case.
Yeah, I can hit that one. So basically, our aerodynamic panel, or the whole aerodynamic structure that we've been analyzing, is obviously we're analyzing it as one continuous body, but yeah, that's something that you can't actually make. So the sort of interfaces between adjacent panels happens at what we call a joggle, and then that sort of involves a step down on one adjacent panel and a step up on another adjacent panel, so that they can mate together in a pretty seamless way. And it also is helpful for structural properties, just making sure that if you have two panels next to each other, that you have adequate basically if you're using adhesive or something, that you have enough area to mate the two surfaces together, and those kind of interfaces are what we're referring to as joggles.
Great, thank you, Caleb.
I'll go ahead and conclude the meeting, but thank you for joining in, and appreciate the time, and thank you, Proof team, for having this presentation with us. I do very much appreciate it.
Yeah, thank you, Chris.